Good morning, students. Write your name and seat number in the chat box. So remaining part of the chapter transition and inner transition elements today we will complete. In the last lecture, we finished the properties, that is melting point, boiling point, then magnetic properties, oxidation state, then the properties of D and A block element. This part is completed. Just we will do the quick revision and we will start the next point. Interstitial compound alloys is also completed. I am coming from oxidation state. Yes. So for the board examination in this chapter, D and A block elements, or the new name is transition and inner transition elements. There is 100% question either on this oxidation state, on this table, or colors, or magnetic properties. This year, the weightage is increased. The weightage is 8 marks weightage for this chapter. Last year's this chapter having 5 marks weightage only, but in this year the weightage of this chapter it is increased to 8 marks. So it is very easy to get good marks in the chapter. So remember, on this table oxidation state there will be the question. Different oxidation states are given in the notes, but in your textbook these different oxidation states are not given. I have given the additional knowledge to you because many times for the CET also, for the NEET exam also, for the GE also, these questions are asked. So especially for this manganese, because manganese shows the maximum oxidation states. So this part is already covered, oxidation states of copper, zinc, iron, these physical properties do not ask for the examination, remember. This hardness is also not asked for the examination, but this melting and boiling point can be asked. Write the periodic trends for the melting and boiling points. First increases, then decreases, again increases, and lastly again it will be decreases because the number of unpaid electrons decreases. If the number of unpaid electrons are increases, its effects on covalent bond, maximum covalent bonds will be formed. So larger the covalent bond, so the strength of the metal will be very high. So if the strength of the metal is high, it requires more energy to melt, to break this bond. So remember, this melting and boiling point can be asked. This is an explanation given for the melting and boiling point. This is not given in your textbook, but I have given for understanding purpose, remember. Then this periodic trends can be asked for the examination. Write the periodic trends of atomic and ionic radii. So with the help of this graph, we can explain. This graph is actually not required. These values are also not required. With this graph, we can write this green line. This is a 3D series, and this is a 4D series, and this is 5D series. But we are interested in only 3D series. From this scandium to zinc, with the help of this graph, we can explain the atomic and ionic radii decreases up to this manganese or this chromium. Again, it is constant for manganese, iron, cobalt, and nickel, and copper also. With this table, We can explain. See, up to this chromium, it is suddenly decreases, and then it is constant, and this increases due to pairing of electron takes place in case of zinc, and due to this pairing, what happens? The repulsive force is more than the force of attraction due to the nuclear charge. So this is the reason. Then ionization enthalpy values, these are exactly opposite to the atomic and ionic radii. The definition is also completed. Magnetic, this magnetic property is very important. Remember what is ferromagnetic substances, what is paramagnetic substances, and what is diamagnetic substances, and how to calculate this magnetic moment. So for the board examination, there may be a question on calculation of this magnetic moment, how the magnetic moment is calculated. They will give the atomic number and this divalent or monovalent. M2 plus means 2 electrons are given. Always remember, if you know the procedure for calculating the number of unpaired electrons, then it is very easy to calculate this magnetic moment, because n only is required, and n is number of unpaired electrons. Number of unpaired electrons can be identified by using this diagram, because the capacity of the d orbital is 5 electrons. First single electrons will be inserted up to 3d5. After 3d5, the pairing starts, means number of unpaired electrons will be decreasing after 3d5. Remember this. This problem is given for your understanding. Then if the question is not on oxidation state, not on magnetic moment, then the 100% there will be the question on color. D block element shows color due to the four things are responsible for this color. First one is number of unpaired electrons in d orbital. Second one is DD transition. Third one is nature of the ligands which are attached to the central metal atom. And number fourth is geometry of the complex. So all these four parts I have explained in your textbook only. The number of unpaired electron is shown. This DD transition is not given in your textbook, remember. So this DD transition purposefully I have given because in your textbook one note is written only there. This part is completed in coordination chemistry. But in coordination chemistry also I have given the notes. In case of this DD transition, I have given the notes. So refer this slide. You will understand how the transition takes place and the color will be appeared. So this part is actually explained. This is the number 3 point of the color, nature of the ligands which are attached to the central metal atom, and the geometry is formed. 2 times I have explained this example, color. And this is for your knowledge only. This will be not asked for the examination. Color of the transition metals due to the charge transfer. The very famous example is KMnO4. You know, this KMnO4 is bright, intense purple color. So this purple color I have shown. This intense purple color is due to the charge transfer. Remember, it is not due to the number of unpaired electrons. It is not due to the DD transition. It is not due to the nature of the ligands. It is not due to the geometry, but it is due to the charge transfer. Remember, for the knowledge purpose, I have given this KMnO4. It is color due to the charge transfer, in which the charge is transferred from oxygen to the manganese. So oxygen, its oxidation state decreases O2 to O minus, and the oxidation state of metal will be changed from +7 to +6. There are also some examples. These are colored due to the charge transfer, Kr2O72 minus, CrO42 minus, then NiDMG complex. So this knowledge is required for the CET, NEET and JEE, remember. Always there will be, many times this question is asked for the examination. KMnO4 is purple color due to the following. They will give the options. So remember this charge transfer. Then This D block elements or transition elements having the catalytic properties. They act as a catalyst. These are some examples of catalysts I have given in the last lecture. This MnO2, where this MnO2 is used, where the ranitidine is used, then where the Fe, chromium, these alloys are used. Then this interstitial formation of interstitial compounds, it is asked for the short notes for 2 marks, remember. Interstitial compounds means these are actually, there is no bonding, these carbon, nitrogen or hydrogen, carbon, nitrogen and hydrogen, these gases are trapped when the crystal lattice is formed, and such type of interstitial compounds are formed, TIC, Mn4N. Actually, there is a not bonding between this carbon and titanium, this nitrogen and manganese, but their properties will be changed. When these elements are trapped in between the spaces, interstitial spaces, when the crystal lattice is formed. So the properties will be changed. These properties also discussed in the last lecture. So please do the revision. It is as for the 2 marks. Then alloys is also important for MCQ purpose. What is mean by bronze? What is mean by brass? What is stainless steel? What is these alloys? So the uses of different alloys are also given here. Bronze alloy, it is a combination of copper and tin. This is cupronickel. The uses are also given here. So this part, D block element, this is a non-evaluative part, remember. This part is non-evaluative. Which one? 8.7. Remember, this 8.7 is non-evaluative for the board examination only, but for the CET purpose, for the JE purpose, for the NEET purpose, the questions will be asked on this part. So that's why I have given for the students who are preparing for different competitive examinations, those preparing for board examination, do not refer these slides. 8.7, these slides, 8.7, compounds of this manganese, chromium, this is not asked. So this slide, again, this second slide, third, these properties are also non-evaluative. So many part of this chapter is deleted up to this 8.7.5, chemical properties of K2Cr27. Up to this one, it is a deleted part for this year only due to the COVID situation. These are the some common properties. This is also completed. This is not asked for the examination, remember. This is for your knowledge only. Then chemical properties are also explained. Now today we will start this part. Extraction of metals, only this slide is there. Again, this part is non-evaluative, remember. Why this part is taken for the examination? Because on this slide, there will be the question, 100% there will be the question of the definition of minerals and ores, and this below this table, below the definitions of minerals and ore, one table is given. So purposefully this part is kept for asking the questions, remember. So 100% one question will be there on this slide. What is mean by mineral? What is the definition of mineral? What is the definition of ore? Or write the formula of the hematite ore. They will ask any one of the formula of the iron ore or copper ore or zinc ore. First, I will discuss what is mean by mineral and what is mean by ore. So before this, you may heard these words, minerals and ores. Minerals, these are the naturally occurring substances which found in the earth crust. So minerals are the naturally occurring substances. These are not artificially prepared in the laboratory. Naturally, it is found in nature, in the earth crust. They contains inorganic salts, then solids, then siliceous matter, etc. It is called as mineral. So mineral means it is a bigger rock. It is found in the earth crust. It is called as mineral. Now I'm coming to the ore. What is the definition of ore? Ore is different than the mineral. Means it is actually the mineral which contains high percentage of metal. So ores, all the ores are minerals, remember. All the ores are minerals, but all the minerals are not ores. Means ore is nothing. Ore is a mineral actually, which contains higher percentage of metal, and from which these are the ores of hematite. This is ore of iron. Then this is a chalcopyrite and chalcocite. These are the two ores of copper. Means they contains more percentage of copper. This hematite contains more percentage of iron. Then this zinc blend contains more percentage of zinc. So ores are the minerals which contains high percentage of metal, remember, from which the metal can be extracted for economically or the commercial use from this. So remember, all the ores are minerals, but all the minerals are not ores. Now then I am coming to this iron ores. This is very famous, hematite Fe2O3. This is the formula. Remember, so we have to remember this table today. Today make a chart of this table, the ores of ores of iron, ores of copper and ores of zinc. Because for the examination, this particular part is only taken, and the remaining part is also non-evaluative part. So hematite Fe2O3, then magnetite Fe3O4. This is a limonite, twice Fe2O3, thrice H2O. Then iron pyrites is FeS2. This iron pyrite we used in the preparation. In the one reaction, it is used. This FeS2, it is used for the preparation of sulfur dioxide in contact process. Remember, these iron pyrites are used. Then siderite, many times this question is asked for the board examination. Write the formula for siderite, write the formula of hematite, write the formula of magnetite, write the formula of limonite. These are the minerals of iron, remember, from which the iron can be extracted. So this hematite contains more percentage of iron. So it is called as ore, and all these are minerals. Then I'm coming to the copper, this chalcopyrite CuFeS2, then chalcocite, this cuprite. This is given, its formula is not given, so it is not asked for the exam. Then zinc blend, it is the ore of zinc which contains more percentage of zinc. Then zincite, one spelling mistake is there, C is repeated, actually it is Zincite, zincite, remember. Make a correction in your textbook also. Then this calamine, it is asked for the examination. Write the formula of calamine, it is ZnCO3. So the remaining part, it is also the non-evaluative part. This is not asked for the examination. This is a deleted part. This pyrometallurgy, hydrometallurgy, electrometallurgy. But this is important for your CET exam. Remember, those students preparing for the CET, for the competitive exam, NEET exam, JEE exam, please go through these slides. These are the very simple definitions. But for the board examination for this year, this will be not asked. This is also deleted. This is also deleted. This part is also deleted. I have given the deleted syllabus to you. Also the textbook, deleted textbook, highlighted textbook is also given. So this blast furnace is also deleted. Reactions of this blast furnace. Then the summary of the reactions. Then this commercial forms of iron. What is cast iron, wrought iron, steel. This is all the part is metallurgy part is deleted except the definition of minerals and ores. Remember, don't make confusion between deleted and which is a present syllabus. Also, it is given at last in the table. It is given. So again, I am coming to the next part of the chapter. Half part is completed, and this is not 70% part is completed. Only 30% part is remaining. This is inner transition elements. Inner transition elements are also called as A block elements. If we can see this periodic table, see from group number 3 to group number 12, these elements are called as D block elements. But there are two series of A block elements. This is a lanthanide series which starts from 57 and it ends with lutetium. So these are the 14 elements from lanthanum to lutetium. These are called as lanthanide series, in which the electron enters in 4f orbital, and this is actinide series which are kept in period number 7. The lanthanides are kept in period number 6. So this actinides, again there are 14 elements. Actinides which starts from atomic number is 89 and ends with atomic number 103. This is a Lawrencium. So these two series, these are called as A block elements, remember. And for the suitable, there is no any suitable space for the periodic table. That's why for your what you can say, just a minute. Yes, these are kept separately below the periodic table because actually these are kept in group number 3. Group number 3, these lanthanides and actinides are kept in the period number 6. The lanthanides are there. So if the position it is asked for the examination, explain the position of lanthanides in the periodic table. So we have to write the lanthanides are kept in group number 3. Clearly we can see lanthanides are kept in group number 3 and period number 6. The actinides are kept in group number 3 and period number 7. These are the two series. One is the lanthanide series. It is called as lanthanide series. All the elements in which the electron enters in 4f orbital and in which the last electron enters in 5f orbital. That's why these are called as also F block elements. So again, I am coming to this inner transition and transition elements. Just I explain all these parts. From 58 to 71, this is lanthanide series, and this 90 to 103. This 90 to 103, first element is actinium, and this first element is lanthanum. So these two series are called as A block elements. There are penultimate shell and pre-penultimate shell. See the definition of A block elements. The elements in which the differentiating electron, the last electron enters into n minus 2. Remember, this is n minus 2 f orbital where n is the principal quantum number. Suppose if the value of n is 6, means if value of n is 6, then the electron will be entering 4f orbital, because 6 minus 2, it will be 4, and the electron enters in 4f orbital in case of lanthanides, remember. So for the lanthanides, the value of n is 6, and for the actinides, the value of n will be 7. So if it is for actinide 7 minus 2, it will be 5. So electron enters in 5 orbital. And this n minus 2 orbital is pre-penultimate shell. Ultimate shell, it is the last shell. Ultimate shell, before the ultimate shell, the shell is called as penultimate shell. And before the penultimate shell, there is a shell, it is called as pre-penultimate shell. So the F orbital is much inside than the ultimate shell. Last shell is ultimate shell. This is called as last shell. Last shell के पहले जो shell आता है, that is called as penultimate shell, and penultimate shell के पहले जो shell आता है, that is called as pre-penultimate shell. So in case of this F block elements, the electron enters in pre-penultimate shell, and this pre-penultimate shell is much inside than the last shell. That's why these elements are also called as inner transition elements. Inner word is used because transition elements के पहले means transition elements in which the electron enters in penultimate shell. But in case of this F block elements, electron enters in pre-penultimate shell. That's why these elements are also called as inner transition elements. Remember, transition के पहले, transition elements के अंदर these elements are there. That's why these elements are also called as inner transition elements. This is a general introduction is given where these elements are kept, why these elements are called as F block elements or inner transition elements. So for the examination, 1 mark question can be asked on this introduction part. And main thing in which this F orbital is partially filled, or F orbital is continuously filled from 0 to 14 elements. The capacity of F orbital is now 14 elements. The capacity of S orbital is 2 electrons. The capacity of P orbital is 6 electrons. Capacity of D orbital is 10 electrons. And the capacity of F orbital is 14 electrons. So in case of this lanthanides, actinides, or in case of these F block elements, the F orbital is continuously it is filled from 0 to 14. So 4F electron enters in 4F in case of lanthanides, and electron enters in this 5F orbital in case of actinides. Then these are the properties of F block elements. This is not asked for the examination, for only your knowledge purpose. For only your knowledge purpose, these properties are given, but no any question will be asked on this part for the board examination. I will read one by one. These properties are similar to the D block elements, means the properties of this transition elements are equal to the inner transition elements, or the properties of inner transition elements are similar to the transition elements. Then electrons are added in F subshell, remember. That's why these are called as F block elements. But this F subshell is not last shell. This is a pre-penultimate shell. If the last shell is 6s2, then electrons will enter in 4f. If the last shell is 7s2, then the electron enters in 5f. So remember these things. These elements are placed between n-1d and ns block elements. So where n is the principal quantum number, remember, if this is n is equal to 6, then these elements are placed in between n-1, this is 6 minus 1 is 5d, and this is 6s2. These are placed in between. In this periodic table, we can understand this. So lanthanides begins with atomic number 57. See the periodic table. Lanthanide series begins with 57 and ends with atomic number is 71. It is lutetium. Detail the names, then atomic number, nomenclature. Sorry, the atomic number, symbol, and electronic configuration is given in the next part. So lanthanides, they starts with 57 and ends with 71. Actinide starts with atomic number 89 and ends with lawrencium. This is a atomic number of lawrencium is 103. So these are the properties are shown. These lanthanides are also termed as rare earth elements. Rare. Rare means these are very less percentage, or very rarely these are available. They are very fairly abundant in the earth crust. Means their percentage is very less, these lanthanoids. So these are the metals. These are soft metals with moderate densities, 7 grams per cm cube. These are the general properties. They are having the high melting point near about 1000 degrees Celsius and boiling points near about 3000 degree. Celsius. Then lanthanoids in the metallic state, these are very reactive, like alkali and alkaline earth metals. In the metallic state, they are very reactive. Then these are the common oxidation state of lanthanoid is +3, remember. Means lanthanides compounds can be formed when these 3 electrons can be given or these 3 electrons can be in sharing. So this question is asked for the examination. Write the general oxidation state of lanthanides. It is +3, remember. +3. This is the general oxidation state of lanthanides. This question is asked for many times for the examination. So remember this +3. But some elements like europium, EU, and ytterbium, they shows exceptional oxidation state +2. So remember these exceptions also, this europium and ytterbium. If you can see this, this europium is atomic number 63 and ytterbium, this atomic number is 70. This shows +2 oxidation state. General oxidation state is +3, and these europium atomic number is 63 and ytterbium atomic number 70. They shows +2 oxidation state. Then higher oxidation states are unusual for lanthanides. Exception is cerium. In cerium, shows +4 oxidation state. Again, I'm coming to this cerium. See, this cerium is atomic number is 58. It shows +4 oxidation state. Generally, all these elements shows +3 oxidation state. But this europium is also shows +2, and this ytterbium is also shows +2 oxidation state, and all other elements shows +3 oxidation state. Then lanthanides have lower heat of atomization than the transition metals, remember. Heat of atomization, I think you know what is mean by heat of atomization. I'm not repeating here again. Europium and ytterbium, see this europium and ytterbium, which is having a +2 oxidation state, they resemble with the alkaline earth metals because of the +2 oxidation state, remember. So this europium and ytterbium, which shows this europium atomic number is 63 and ytterbium atomic number is 70. They already having the +2 oxidation state. They resembles with alkaline earth metals because alkaline earth metals is also having the +2 oxidation state. They dissolve in liquid ammonia to give the blue conducting solutions. Blue colored solutions, they give the blue colored solutions. Then their ionic radii decreases from 170 picometers of lanthanum to 100 picometers for plutonium. This is the general properties, general trends are given. The ionic radii decreases from this lanthanum to lutetium. So this lanthanum to lutetium. See in this table, we can see in this table, see the atomic radii of lanthanum is 187. Yes, it is a decreases. Atomic radii decreases from this 187 to 173, and this ionic radii also decreases 106 to 86. All the lanthanides from this form hydroxides of the general formula LnOH thrice. So This lanthanides, they forms the hydroxide, lanthanum hydroxide to lutetium hydroxide. The general formula of this hydroxide is LnOH thrice, remember, and it is a ionic, also basic in nature, and this is due to the ionic size decreases from La3 plus to lutetium 3 plus. So, as the ionic size decreases, the basicity also decreases. So, which is a strong base and which is a weak base? This will be asked for the examination. So, basicity decreases from this lanthanum. So, this lanthanum hydroxide, it is a weak base, and this lutetium, this is a strong base. This lanthanum hydroxide LaOH thrice, this is a strong base, and lutetium OH thrice, this is a lutetium hydroxide, is the weak base. So basicity is decreases from this lanthanum to the lutetium. This is due to the ionic size decreases. So ionic size decrease in case of lanthanides. The there is a with increase in atomic number, because atomic number we can see increases from this 57 to 71. Actually, in case of general trends, is the atomic number, if it is increases, the ionic radii is also increases. But this lanthanides shows lanthanide contraction. There is a decrease in atomic size and decrease in ionic size because of this lanthanides. This is due to the, there are two effects for this lanthanide contraction. I will explain in the later slides what is mean by lanthanide contraction. Why this contraction of this atomic size takes place. Generally, if the atomic number is increases, the ionic and atomic side should be increased. But if you can see in this table, see the values also, as the atomic number is increases, but the atomic radii are not increasing, they are decreasing. This is due to the nuclear charge effect is more than the shielding effect. Actually, the shielding effect is due to very poor shielding effect, because electron enters in 4f orbital in case of lanthanides, and in case of actinides, electron enters in 5f orbital. Like lanthanide contraction, actinides also shows the similar property. It is called as actinide contraction. Remember, this is due to the nuclear charge effect, because as the electron it is added in the same shell, we can see here this is expected electronic configuration. And this is a observed electronic configuration as the electron is added in the f orbital. So as the electrons are added in the the f orbitals are very poorly shielded. But there is another effect. One is that effect is called as nuclear charge effect. So nuclear charge effect, it is more powerful in case of lanthanides. So there is a decrease in atomic size, a decrease in ionic radii, and this property is called as lanthanide contraction. Remember, for the 10 or 20 times from 2000, this lanthanide contraction, it is asked for the examination from 1996. So this lanthanide contraction is very important part, remember. In case of this inner transition elements, this question is very important. What is mean by lanthanide contraction? What are the factors which are responsible for this lanthanide contraction? Means its causes. Why the lanthanide contraction is caused, and what are the effects of lanthanide contraction? First effect is basicity decreases. Basicity decreases. So it is also shown in this property. Basicity decreases from this lanthanum to lutetium. So lanthanum hydroxide, this is a strong base, and lutetium hydroxide, this is a weak base. This property is due to the lanthanide contraction, remember. Lanthanide reacts with nitrogen and halogens to give the nitrides and halides. But now in this syllabus, the reactions part is also eliminated. Reactions are also deleted. So forget about the reactions. +3 oxidation state, many of the lanthanides are colored. So these are the